Dear students, welcome back to the Commercial Mathematics and Statistics class for HS second year. আমি যোৱা ক্লাছটোত আমি ইয়াৰ আগৰ ক্লাছটোত arithmetic meanৰ গোটেইকেইটা ফৰ্মুলা শিকিছিলোঁ আৰু আজি আমি properties of arithmetic mean নৰ সৈতে আৰম্ভ কৰিব খুজিছোঁ. Arithmetic mean has some mathematical properties which has got immense use in our day-to-day life, and so it is very important that we understand these properties, what they actually imply. So going to the first property, it is stated this way: the sum of the deviations of the observations from their arithmetic mean is equal to 0. This is the statement of the first property, which says the sum of the deviations of the observations from their arithmetic mean is equal to 0. So symbolically, we can write it as, supposing we have a varied value x, we have a variable x which take values x1, x2, etc. up to xn, and let, as we all know, the arithmetic mean is denoted by x bar. Alright, that is for the varied value x taking values x1, x2, etc. up to xn. That is, we have got n observations and x bar denotes their arithmetic mean. Then according to this property, what should we have? Then summation of x bar minus x is equal to 0. That is, if we take deviations of the items from the arithmetic mean, that is x bar minus x1 plus x bar minus x2 plus etc. up to x bar minus xn. We are taking deviations of each of the items x1, x2, etc. up to xn from the arithmetic mean x bar, and if we sum them up, the summation is always going to be equal to 0. This is the first property of arithmetic mean. The next property of arithmetic mean is, we go to the second property. The second property says the sum of the squares of the deviations of the observations from arithmetic mean is the minimum. Yes, the statement is the sum of the squares of the deviations of the observations from arithmetic mean is the minimum. The meaning is that if we write symbolically, you will understand. Symbolically, again, just like the previous property, if we consider, let x be a variable taking values x1, x2, etc. up to xn, and let their arithmetic mean be denoted by x bar. And now we shall also consider a, which is an arbitrary constant. That is, a is any constant number. By any constant, we may refer to it as any other measure of average. That is, it might be median, which we will learn later. It might be mode, it might be geometric mean, it might be harmonic mean, any other measure, or it might be any other constant. Alright, it might be assumed mean, whatever. In that case, what will happen if we take the deviations of the items from x bar and we take the deviations of the items from any arbitrary constant and square them up and then add them, we will see that the value which we get by taking the deviations from x bar and squaring will be smaller than the other expression. That is, then by this property what we have, summation over x bar minus x is minimum is less than equal to summation over x bar a minus x. That is, and we are taking the square of the items. That is, we are taking the deviations like the previous property. We are taking the ones, we are taking the deviations from mean, and in the other one we are taking deviation from any other arbitrary constant, and we are squaring those values and adding them up. Alright, and then this expression will always give a lesser value, a minimum value than the value which we will get from the expression on the right hand side. This is the second property of arithmetic mean. I think the first two properties are clear to you. We move on to the third very, very important property of arithmetic mean. The third property says arithmetic mean AM is not independent of change of origin and scale. Change of origin and scale. Very, very important property. Alright, so what does this imply? There are two words, change of origin and change of scale. Change of origin refers to change in the variate value x. So let us write symbolically. Yes, symbolically. What happens? We will take up different cases. I just give you an idea. Supposing x is a variable, taking values x1, x2, etc. up to xn. What does change in origin implies? Change in origin implies you are either adding something to all the values, say a constant c, or you are subtracting a constant c to all the items. Alright, that is, when you add or subtract a constant value to all the items under x, we call it change of origin. And then this is case 1. Case 2 is if you multiply all the values of variable x by a constant c1, say c into x1, c into x2, etc. up to c into xn, or you divide the constant x1, the variable value x1 by c, x2 by c, etc. up to xn by c. These two cases where you are multiplying or dividing the given value of x by some constant value c, then the arithmetic mean also gets changed. Orthat, ami jodi x mantur logot jikunu eta constant যদি আমি প্লাস এড কৰোঁ যোগ কৰোঁ বা বিয়োগ কৰোঁ বা পূৰণ বা হৰণ কৰোঁ প্ৰত্যেকটো ভ্যালুৰ লগত যোগ কৰোঁ বা বিয়োগ কৰোঁ পূৰণ কৰোঁ বা হৰণ কৰোঁ তেতিয়া হলে কি হ'ব এয়া হৰণ কৰিছো ইয়াতে পূৰণ কৰি দেখুৱাইছো এয়া পূৰণ কৰিছো প্ৰত্যেকটো x ৰ ভ্যালুৰ লগত ইয়াতে হৰণ কৰিছো প্ৰত্যেকটো x ৰ ভ্যালুৰ লগত তেতিয়া কি হ'ব x ৰ যেটো arithmetic mean আছিলে সেই মিনটো কি হ'ব হলনি হৈ যাব এতিয়া হলনিটো কেনে ধৰণে হ'ব এই প্ৰপাৰ্টিটোৰ পৰা আমি শিকিবলৈ চেষ্টা কৰিম প্ৰথমতে আমি লৈছো symbolically let x be a variable taking values x1 x2 etc up to xn and let the arithmetic mean be denoted by x bar তেতিয়া আমাৰ প্ৰথম কেছটো কি হ'ব আমি প্ৰথমতে change of origin or কথালে যাম if all the values of x become like this আমি প্ৰত্যেকটো x ৰ লগত যদি c plus কৰো c is a constant বা minus কৰো comma x2 plus minus c xn plus minus c we are adding and subtracting c to all the values of the variable x then for this new series eto eta notun series hol a series tour karone x bar will be the arithmetic mean will be x bar plus c অর্থাৎ যেটো series x or x1 x2 etc up to xn asile tare jodi arithmetic mean to x bar hoy ami jetia plus ba minus korim tetia hole ki hobo arithmetic mean jodi plus koru original mean to logot c plus hobo jodi minus koru tetia hole original x bar or logot constant c to minus hobo this is the first part that is change of origin am is not independent of change of origin talking about change of scale if we go to the second case we are going to change of scale now that is if x1 x2 etc up to xn are n varied values of the variable x x bar being their arithmetic mean and now we have a new series in which we are multiplying all the values of the variable x by the constant c then the new arithmetic mean for this series that is arithmetic mean for the new series will be c times x bar original mean multiplied by the constant c similarly taking the third case if all the items get divided by c if all the items get divided by c all right the new series is this with arithmetic mean x bar the original series is this the new series is taken by dividing all the items by the constant c then the arithmetic mean of this new series will be x bar divided by c so this is the property of arithmetic mean which says that it is not independent of change of origin as well as change of scale this is a very very important property and in your exam you get sums where you just have 1 mark you'll be given a series and then you will given a new you will also be given the mean of that particular series and then you'll be given a new series in which either the values get added or the values get subtracted or multiplied or divided and you're asked to find the arithmetic mean for the new series then by making use of this property you can do it very easily it will be just a 1 mark question so you cannot spend time doing the entire sum but you just make use of this property you will know what will be the answer. Moving on to the fourth property, another very important property. We call it the property of combined mean. Here we have to know something about dividing a particular population into, say, some different subpopulations, some subgroups. All right, that is, supposing we have a population consisting of n number of items. There are n number of observations in the population. All right, and then what we do, we subdivide this n number of items into, say, some subgroups, say n1 and n2. Supposing, first let us consider just two subgroups, n1 being the number of observations in the first subgroup and n2 being the number of items in the second subgroup. All right, also let x bar be the mean of the entire population taken as a whole. Guteitu homostir jitu arithmetic mean hetuk ami x bar buli koisu, that is x bar is the arithmetic mean of the whole population. লগতে আমাৰ হাতত যদি এনেকুৱা ইনফৰমেশনো আছে যে x1 bar is the arithmetic mean of the first subgroup and x2 bar, you also have some information about the mean of the second subgroup, that is x2 bar is the arithmetic mean of the second subgroup বা subpopulation, whatever you call. All right, now with this much of information we should be able to find the combined mean sometimes when this is not given to us. All right, if we have the values for x1 bar and x2 bar, that is, we know about the mean of the subpopulations or subgroups, and now we are interested in finding the arithmetic mean of the entire group taken as a whole. All right, so just to make it all the more easier, so let us say in a classroom of CMST class we have girl students as well as boy students. All right, so let n1 be the number of girls in the classroom, n2 be the number of boys in the classroom. All right, let x1 bar be the mean height, that is arithmetic mean height of the girls, and x2 bar be the mean height of the boys. I have this much of information, and suddenly now I want to know about the mean height of the girls and the boys taken together as one class. All right, so instead of recalculating the entire the mean, I mean finding mean for the entire group again, all over again, by making use of this much information we can find out what is known as the combined mean or combined arithmetic mean. Arithmetic mean is sometimes referred to as mean, only mean. Okay, then we will denote it by x double bar. Since x bar implies mean, so x double bar will imply combined mean. All right, this is the combined mean, and the formula for combined mean is given by n1 times x1 bar plus n2 times x2 bar divided by n1 plus n2. That is, with information about the subpopulations in a particular population, we can find the mean of the entire population, which we call the combined arithmetic mean or combined mean simply. We can extend this formula to any number of subpopulations. Supposing there are k number of subpopulations. K is any number. If we have divided a particular population into k subpopulations or k subgroups, then what will this formula look like, you see? Then x double bar will be equal to n1 times x1 bar, n2 times x2 bar, etc. up to nk times xk bar divided by n1 plus n2 plus etc. up to nk. So this is again a very, very important property of arithmetic mean, and this property suggests that arithmetic mean can be, put for further algebraic treatment. We are multiplying by some constant, we are adding them, dividing, yes? That was a proper characteristic of arithmetic mean, implying arithmetic mean can undergo different kind of further algebraic treatment. So this is a very important property. We have to do sums using this property, to which we will come later. So these are the 4 very, very important properties of arithmetic mean, for which you have to know the mathematical implication. For combined mean, you get sums up to 5 marks, and for the other properties, you will get questions, small sums consisting of 1 to 2 marks. So with this, I think the discussion on arithmetic mean can be said to be almost completed. Sums are there. We will take up applications later after learning some more measures. Now we have to know a little bit about the merits and demerits of arithmetic mean. What are the merits? The first merit is it is rigidly defined. We go back to the characteristics. It is rigidly defined. The definition is very rigid. You have a specific formula for it. Arithmetic mean উলিয়াবৰ বাবে মান উলিয়াবৰ বাবে এটা নিৰ্দিষ্ট ফৰ্মুলা আছে লগতে কি আছে ইট ইজ সিম্পল এন্ড ইজি টু আন্ডাৰষ্টেণ্ড সকলোৱে এই ফৰ্মুলাটো ব্যৱহাৰ কৰি পেলাই কি কৰিব পাৰে তেওঁলোকে কিনি আমি মেৰিট ডিসকাস কৰি আছো মেৰিটস অফ an simple to calculate and easy to understand. A property to a characteristic to arithmetic mean satisfy kore. A matra ami jetu fourth property last property to porhilu tarpora ki gom palu je arithmetic mean can be applied into further mathematical or algebraic treatment. It can be put to further algebraic treatment. This is also a merit of arithmetic mean. So these are some of the merits. Going to the demerits. Demerits consist of the fact that arithmetic mean sometimes get unduly affected by extreme values. Amar jodi eta series of 5 ta value dia ase for the variable x, x1, x2 etc. up to x5, x1, x2, x3, x4 and f5. These are all values, okay? I am not writing the values. So what happens? Sometimes if two or three of these values are in the extremities, either very high values or very low values, in that case, arithmetic mean gets unduly affected. So this is a drawback or a demerit of arithmetic mean. Now we are talking about the demerits. All right. The second demerit of arithmetic mean is such that we had talked about open-end classes that day. Open-end classes, I think you remember, when class intervals are of the form, say, below 10. All right? And then you have 10 to 20, 20 to 30, 30 to 40, and then you have above 40. This is an open-end class. In that case, what happens? When you have open-ended intervals, you have open-end classes, it is difficult to calculate arithmetic mean. Why is it difficult? Because how will you find out x here, the mid value? Mid value is lower limit plus upper limit divided by 2. Upper limit is 10, no doubt. What is the lower limit? Below 10? Is it 9? Is it 0? Is it 5? So it becomes very difficult. Usually, for practical purposes, we take it to be equal to the other given classes, but that is just a practical solution. Mathematically speaking, it is difficult to find arithmetic. Similarly here, when you say above 40, 40 is the lower limit. What will be the upper limit? Is it 50? Is it 60? It is 100 or is it 1000? We do not know. So in such cases, arithmetic mean sometimes might give us erroneous results. This is another demerit of arithmetic mean. But looking into the usefulness, the simplicity and its use, and the easy mode of calculation, and the very maximum, you may say maximum use of this mean, of this measure, arithmetic mean is considered to be the best measure of central tendency or best measure of average. আমি arithmetic meanok সকলো আমি বাকিবোৰ measure পঢ়িম এই সকলো measureতকে সকলো মানতকৈ আমি arithmetic mean টোক আমি ভাল বুলি কৈছো বেষ্ট বুলি কৈছো কিহৰ কাৰণে আমাৰ যিকেটা characteristics আছিলে তাৰে গুটেইকেটা অলমোস্ট গুটেইকেটা characteristic হি satisfy কৰিছে apart from two that it gets unduly affected by extreme values and it becomes difficult for use in case when we have extreme, we have open-ended classes. Otherwise, it is very, very important and we use it in our day-to-day life knowingly or unknowingly. So as such, arithmetic mean can be considered to be the best measure of central tendency. In your exam, you might get a question. What are averages? You get it as a tail question usually. What are averages? Why is arithmetic mean considered to be the best measure? Then you have to mention all the characteristics of the ideal measure of central tendency which we had already learned and say that arithmetic mean satisfies this, does not satisfy one or two, and that is why we consider to be it is the best measure rather. Alright, so this is all about arithmetic mean. So now we are fully equipped with arithmetic mean. We know its definition, we know its formula, we know the properties, we know merits, demerits. Alright, so now after learning two more measures, we shall go to sums relating to arithmetic mean, how to find arithmetic mean. Alright, so arithmetic mean is a mathematical measure. I think you remember mathematical and positional measures we had discussed. Alright, so we learnt about the mathematical measure arithmetic mean. Now we have two more measures, geometric mean and harmonic mean, under mathematical mean. We shall do that later. Let us go to the positional measures now. The first positional measure being median. It is a positional measure. I think you remember why we call it positional. Yes, arithmetic mean cannot be found graphically. That is one of the demerits you can say. But median and mode can be found graphically without calculating also, and that is why they are known as positional averages. So median অর্থাৎ মাধ্য মিডিয়ানে কি কৰে এটা ডিস্ট্ৰিবিউশনক সমানে দুভাগত বিভক্ত কৰে দুভাগত ভগায় so a median is what it is the middlemost value all right if we have a distribution where x takes say values x1 x2 x3 etc up to say xn আমি কৈছিলো central tendency measure bur a মাজ ভাগত থাকে central most part median to kot thakibo exactly in the middle একদম মাজতে থকা যেটো ভ্যালু যেটোৱে এই ডিস্ট্ৰিবিউশনটো সমানে দুভাগত ভগাব yes 50% below median 50% above median all right so median is nothing but the middlemost value ekebare majote thoka jitu value jitu measure that is known as median all right so median is also sometimes referred to as a partition value it is referred to as a partition value partition mane ki jihe এখন ইয়াতে partition create কৰিছে আৰু কেনেকুৱা ধৰণৰ partition create কৰিছে যে তাৰ partition খনৰ তলত 50% observations বা items বোৰ থাকিব আৰু এই partition খনৰ ওপৰত তা মানে medianৰ ওপৰত বাকি 50% observations থাকিব এতিয়া আমি যেহেতু partition value কথাটো কলো medianৰ definitionত যোৱাৰ আগতে অকমান partition value নো কি এখিনি আমি অলমান চাই লওঁ so partition value আকো 3 bit partition value আছে আমি medianলৈ ঘূৰি আহিম কমন partition value বিষয়ে কৈ দিছো partition values are of 3 types quartiles deciles and percentiles all right so let us take a frequency curve we are taking a symmetric curve all right median to ami koisu middlemost value so median will be here all right so below median we have 50% of the observations above median we have 50% of the observations okay so what are quartiles median e dubhagot bhogale quartiles e 4 bhagot bhogabo quartiles are such partition values which divides the distribution into 4 equal parts quartiles e 4 parts ot bhogai 4 ভাগত ভগাই আৰু কেইটা কোয়ার্টাইল আছে আমাৰ আমি চাইলো this is q1 median to whole q2 to whole q3 সমানে 4টা ভাগত যেটো পার্টিশন ভ্যালুৱে ভগাই সেই মেজাৰটোক আমি কোয়ার্টাইলস বুলি কওঁ so আমাৰ কোয়ার্টাইলস কেইটা আছে 3টা কোয়ার্টাইল আছে q1 q2 aru q3 there are 3 quartiles and the second quartile coincides with median that is median is equal to q2 and median are same all right so below q1 what is the percentage of observations below q1 it will be 25% above q1 it will be 75% obviously median and q2 are same so it is 50 and 50 below q3 we have got 75% observations and above q3 we have got 25% observations this is quartiles similarly there is another measure called deciles deciles divide a distribution into 10 equal parts deciles will divide a distribution into 10 equal parts all right so enake there will be 10 equal parts first decile will be denoted by d1 second decile by d2 etc up to fifth decile by d5 all right and this is d9 all right so deciles divide a distribution into 10 equal parts equal শব্দটো ৰখি গৈছে 10 equal parts 4 equal parts যেনেকৈ ইয়াতে 10 equal parts and there are 9 deciles D1 D2 D3 etc up to D9 okay and then we go to percentiles just like quartiles and deciles which divide a distribution into 4 parts and 10 parts respectively percentiles divide a distribution into 100 equal parts. Percentiles divide a distribution into 100 equal parts. All right. So we represent them by P1, P2, etc. up to P99. So if we have P1 here, P2 here, P3 here, etc. up to median will be equal to P50 and then you have P51 etc. up to P99. There will be 99 percentile values and it will divide the entire distribution into 100 equal parts. So this is very, very important. You have to remember what partition values are and here a very, very important question is what is the relationship of these partition values with median? That the relationship between the different values that is partition values with median. Median that is M is equal to the second quartile. Q2 is equal to the 5th decile. D5 and the 50th percentile P50. This is a very, very important relation which you should always remember. সদায় মনত ৰাখিবা যে medianৰ লগত বাকিবোৰ partition value কি relation আছে. Median is nothing but Q2 and it is also equal to D5, the 5th decile and the 50th percentile. So regarding partition value and its calculation we shall come later again, but now we go back to median. This was just an idea about what partition value is all about because median is also a partition value. Back to median. Madhyama. So we may say median may be defined as the middlemost value. As the middlemost value of a distribution which divides the distribution into 2 equal halves. একেবাৰে মাজতে থকা যেটো ভ্যালু হেতুকে আমি মিডিয়ান বুলি কওঁ. So if this is a frequency curve, this is our median will be here. All right, it divides the distribution into 2 equal halves. Usually it is denoted by M or in some books you will find it as ME. All right, so this is the definition. Now just like arithmetic mean, we will try to know how to calculate median. That is, we will learn the formula. Median ami kene dhorone calculate kori uliam for different kind of series. That is discrete frequency, discrete non-frequency, as well as continuous distribution. So we'll take them up one by one. The discrete non-frequency distribution. All right, discrete non-frequency distribution. What is the form? The form is like this. Kenekwa hoy discrete non-frequency distribution to dekhat. This is the structure. So x or kisuman value dia ase. The median uliabo karne ami ki korim. All right. So we will follow an algorithm. Ami step by step kori jam. Ami ki korim? Step 1. Step 1 not ami ki koribo lagibo? We have to arrange the given series in order of magnitude. Arrange the distribution or series in order of magnitude. All right, that is in ascending order or in descending order. Dangoro pa horule ba horur pa dangorole ami x or man khinik hojai lom. In step 2, find n. N mane number of observations. Kimanta observations dia ase. Ami he n to goni uliam je x or amar hatot 5টা ase ne 10টা ase ne 15টা ase ne 20টা ase. Kimanta value x or dia ase hetu ami uliailom. Find n, where n is the number of observations. Step 3, observe whether n is even or odd. Is ami n ulialo tar pisot ami sabo lagibo n to even ne odd, jogmo ne ojogmo. ঠিক আছে এতিয়া step 4 ত আমাৰ দুটা বস্তু আহিব. Case 1, when n is odd. Our second case to obo when n is even. We go to that later. So first let us find out what happens when n is odd. All right. So when n is odd, supposing we have values of x like this, x1, x2, x3, x4, x5, x6, say x7, hatta value dia ase. Jehetu ami odd or kotha koiso ami odd number of values lo. So here n is equal to 7, which is odd. Already ami first step to kori loisu. Ami thori loisu je x1 or pa x7 oleke ami in order of magnitude dangor pa horule ba horur pa dangorole ami hojai loisu. Tar pisot dekhisu je 7টা observation dia ase. Odd number of observations. Iti amar majot kuntu value hobo? Tolor e 3টা jodi bad diu, upor 3টা bad dilu, x4 is the median value. Value of x4 will be median. All right. But etu eta 7টা ase karone ami mukhe mukhe uliaisu. Jodi amar 333 ta thake kuntu value hobo? Yes, when you have large numbers we have to have a formula. So formula to kenekwa, so we shall write down in step 4 when n is odd, what we do is so in step 4 case 1 where n is odd, the formula for finding median will be m equal to value of n plus 1 by 2th observation. Value of n plus 1 by 2th observation, where n refers to the number of observations. Taking the illustration which we were discussing, there were 7 observations, plus 1 is 8, divided by 2 is 4. So value of the 4th observation, that is x4, will give us the median value. All right. Now what will happen when n is even? So let us take the second case, case 2, when n is even. Amar hatot jodi even number of observations থাকে x1 x2 x3 x4 x5 x6 supposing there are 8 observations here n is equal to 8 which is even. All right, so if we have even number of observations by inspection, what should median be? Median has to be the middlemost value. All right, so there are 3 values this side on the lower end, 3 values here in the upper end, and in the middle we have got 2 values which will be the median value. All right, if we want to use our common sense, median should be somewhere here actually, talking about the position. যেহেতু একেবাৰে মাজৰ ভ্যালুটো হ'ব লাগে, মিডিয়ানটো এইখিনতে হ'ব লাগিছিল, তো সেইখিনতে আমাৰ ভ্যালু নাই, x4 আৰু x5 আছে. So what will this, the value over here, how will we find it? It will be the arithmetic mean of these 2 values. All right, so in case of even number of observations, median will be given by arithmetic mean of n by 2it and n plus 2 by plus n by 2 plus 1it observations. Ta mane ei dutar ji duta value majot thakibo hei duta value ami arithmetic mean jodi uliao, that will give us median in case where number of observations is even. ঠিক আছে, so this can be written as arithmetic mean যেহেতু দুটা value উলিয়াম, it is 1 by 2 n by 2it observation plus n by 2 plus 1it observation. Major observation দুটা plus করে divided by 2 করিলে we will get the arithmetic mean of these 2 values. All right, the middlemost values. This is the formula for finding finding median in case there are even number of observations. This is all about finding median in case of a non-frequency distribution. Next we go to a discrete frequency distribution, the second formula. How will we find median in case of a discrete frequency distribution? In case of a discrete frequency distribution, the structure is like this. Dekhat kenekwa hoy discrete frequency distribution kon. X takes values x1, x2, etc. up to xn with respective frequencies f1, f2, etc. up to fn, such that summation of f is equal to capital N. Total of frequency is always denoted by capital N. এনেকুৱা এখন frequency distribution যদি আমাক দিয়া থাকে, তেতিয়া আমি কি দৰে median উলিয়াম? তেতিয়া আমাক কি কৰিব লাগিব? We have to construct a cumulative frequency distribution table. I think you remember what is cumulative frequency distribution. Yes, so for finding median we will construct a cumulative frequency distribution table. All right, so this is a table of cumulative frequency distribution where we will have 3 columns: x, f and cumulative frequency. All right, below this given values we will also find the total. All right, I think you know what is cumulative frequency. This will be f, this will be f1, second one will be f1 plus f2, third one will be f1 plus f2 plus f3, and so on. The last one will be summation of all the frequencies. The last cumulative frequency will be n. This is how we construct the cumulative frequency distribution table. Then we have to find here n by 2 কিমান হয় মান যদি n supposing আমাৰ যদি n 100 আহিছে n by 2 কিমান হ'ব 100 by 2 will give us 50 এই 52 উলিওৱাৰ পিছত আমি কি কৰিম we will look for cumulative frequency just greater than n by 2 তাৰ মানে just greater than 50 supposing আৰু যেটো ভ্যালুতে গৈ পালাই হেতু আমি পাম যে 50 কে just ডাঙৰ ভ্যালুটো জতে পাম তাৰে corresponding যেটো ভ্যালু হ'ব that will be the median for that particular distribution. Supposing we have a discrete frequency distribution where values of x and f are given to you. The values of x are 1, 2, 3, 4, 5 and 6 and the respective frequencies are 4, 7, 15, 8, 6 and 3 and you're asked to find the median. So since this is a discrete frequency distribution, how will we find median? First of all, we shall construct a cumulative frequency distribution table. This is a cumulative frequency distribution. Values of x are 1, 2, 3, 4, 5 and 6. Values of f are given. This is 4, 7, 15, 8, 6 and 3. So we'll find out the cumulative frequencies. So this is 4. 4 plus 7 is 11. 11 plus 15 is 26. 26 plus 8 is 34. 34 plus 6 is 40. 40 plus 3 is 43. So our total frequency is 43. So what we do here is, here now we will calculate here n by 2 is equal to how much? N by 2 is equal to 43 by 2, that is 21.5. Now we shall look for the cumulative frequency which is just greater than 21.5. And what is it? It is 26. So we will write now cumulative frequency just greater than n by 2 is 26. Yes, this is 26 corresponding to x equal to 3. Corresponding to x equal to 3. Therefore, what is median? Median is equal to 3. This is how we find median in case of a discrete frequency distribution. We shall take up more sums later. So this is just for your understanding how to go for it after construction of the table. You will find n by 2 and then you will look for the cumulative frequency just greater than n by 2 and the corresponding value will give you the median value. The third form is a grouped frequency distribution or continuous frequency distribution. That is when class intervals are given, along with that frequencies are given to you. If the structure is like this, say 0 to 10, 10 to 20, 20 to 30, etc. Alright, in such a case, we shall make use of a formula for finding median. Median is equal to L plus n by 2 minus CF by F into H. Alright, this is the formula for finding median in case of a group frequency distribution where L is the lower limit of the median class. Lower limit of the median class. N we already know, N is nothing but summation F. What is CF here? CF refers to the cumulative frequency of the class, cumulative frequency of the class preceding the median class, preceding the median class. Median class or আগৰ ক্লাছটোৰ cumulative frequency. I'll tell you what is a median class. What is F? F is the frequency. Is the frequency of the median class. Median class or frequency. Aru H to whole width. H is the width of the median class. Alright, so we have to know the formula, and before application of the formula we should know what the median class is. Yes, so in finding median, the first important work will be to find the median class and then putting the values for finding the median of that particular distribution given to us. So again, if a class interval is given to us and frequencies are given to us, for finding median, remember we always have to find the cumulative frequency. That is, we have to construct the cumulative frequency distribution table. Similarly, like the previous procedure, here also we will find out all the cumulative frequencies and then find n by 2. We will calculate n by 2, and then what we do is we will again look for the cumulative frequency just greater than n by 2. The corresponding class will be the median class. Alright, so if this is the median class, the frequency of that class, that is F, will be here. CF will be the cumulative frequency of the class preceding the median class. So CF will be here. Alright, width implies the difference between the highest and the upper limit and the lower limit of the median class. So using this formula we can find median. So with this we stop here, and in the next class we shall learn about the graphical representation of median, and then we will learn mode, its graphical representation, and then we shall go for application, that is mathematical application, that is we will do sums relating to arithmetic mean, median, as well as mode. So dear students, let's revise and recapitulate what we have learned today. So at the very beginning we had started with the properties of arithmetic mean, the 4 very important basic properties, and then we had discussed about the merits and demerits of arithmetic mean and why it is called the best measure of central tendency. And then we further moved on to median. We had an idea about partition values, quartiles, deciles and percentiles, their relationship with median, which is very important for your knowledge as well as examination point of view. And then we learnt about median in details, all the 3 different techniques of finding median in case of a discrete distribution and in case of a continuous distribution also. So we hope to meet once again in the next class with the different other topics which we have to learn in this chapter. Thank you so much.